Hi, welcome back to the session of antennas and wave propagation. So in the previous session, we discussing about the introduction about these antennas. So in this session, we are entering into the basics of antenna mechanisms, which means we are discussing about what is the properties of antennas and basics of antenna properties. Antennas elements are there. So while we discussing about this overview, so in this session, we mainly focusing about what is the functions of antennas. So how many functions are there? And what antenna is importance of those functions of antennas, what is the vital role maintaining this antennas construction. And second one is we discussing about this basic antenna elements. While construction of this antennas and often designing of my antennas, what is the uses of this antennas we discussing in this session. So first one, functions of antennas. So as we discussed, antenna is used as a transducer. So what is transducer? We can able to transmit signal, we can able to receiving signal. So which means it converts the electrical current energy into electromagnetic energy at the transmitting end, and similarly in the receiving end, it should be electromagnetic energy into electrical energy. As we discussed in the previous session, we having as two blocks are there. One is transmit section block as well as we having as a receiving section block. In the transmit section block, we need to convert this electrical current into electromagnetic wave values only, but in the receiving section we are converting this electromagnetic wave into electrical current values only. That is a major function of my antennas, because while we help of this electromagnetic wave values only, right, so these signals only we are entering into this air medium with help of this electromagnetic wave. What is electromagnetic wave? Is apparently nothing but the electric field value and magnetic field value, a signal. So this signal is entering into the air medium values only. What is transmit section? We are able to convert in this electrical current into electromagnetic wave. So this energy is entering into the air medium, and from the air medium we are converting into the electromagnetic waves to the electrical energy values only. That should be in the receiving. It should be vice versa combinations only. And next one, it is also acting as an impedance matching device. So for example, here we are able to apply some respective voltage values, and based upon this one we having a some kind of impedance value is there. So in the receiving section also we are properly calculate about this the output voltage value, output impedance value. So what is my input voltage value and what is my input impedance value? Similarly, what is my output voltage value and what is my output impedance value? So when we proper impedance of these values, so where Zin is equal to Z0 value, which means my input impedance must be satisfied with my output impedance value, then only we can able to say this device acting as a proper impedance matching. The thing is this way, like if I'm transmitting 5 volt signal is there, but in the receiving end I'm receiving only 3 volt signal. So there is a drawback of this 2 volt signal is dropped down here. So which means the amount of information is damaged. We can't able to decode the signal accurately because some amount of information is damaged. Because of that, we are designing any kind of antennas, we are focusing about this impedance matching only, which means the input value must be is equal to my output value, then only we can able to receiving the values only. That is the one function of antenna. And other function, right, antenna is also working under this, right, as we discussing about this definition of antenna is also acting as a sensor, also antenna acting as a transducer. Same way in the functions of antennas, any kind of antennas, right, we have to maintain the identical element values, right, and which means antenna is working under this specific directional pattern values only. This functional is antenna under this working about this the directional pattern values only, which means what kind of direction my signal is transmitted, right, whether it's a omnidirectional value or else unidirectional value or else it covering as a isotropic directional value. So which means antenna can able to monitoring this directional pattern values only, can able to develop the spectrum values only based upon this transmit section or based upon this receiving section. So what are the elements we are using, that one with the help of the element we are able to design the my respective direction of my antennas. So also antenna is also acting as a omnidirectional pattern of my antenna values only. So these are the important functions of my antennas. And the next one, while discussing of this basic antenna element. So basic antenna element. So first one is we also calling as a alternating current element value, which means how much amount of transmitter is there. When any kind of signal is entering into this wave medium values, how the amount of signal is transmitted, right? How the electrons or momentum is there. How the electron momentum is there, we are able to understand the scenario. So here we consider about this the AC current value with help of this heterogeneous dipole element values only. Similarly, we consider the short dipole value, monopole value, half wave dipole as well as quarter wave monopole. So while designing this any kind of antenna structure, right, based upon this signal propagation, we consider this respective length of my antenna values only. So what is the length of antenna? So based upon this length of antenna values only, based upon this lambda values only, right, we are able to designing about this my frequency value, or else based upon the frequency values only, we designing about this respective lambda value. Why in the sense, as we know, where lambda is equal to c by f. What is c? C acting as a velocity of light. What is velocity of light? Which is 3 into 10 to the power 8 meter per second. But what is f here? F in the sense nothing but frequency values only. As we discussed in the previous slide, previous section, we discussing about this radio frequency spectrum values only. So their frequency plays a vital role. So based upon this frequency values only, we design the respective lambda value. So based upon this lambda values only, we design the respective size of my antenna values only. So here every value is interlinked to my frequency values only. First we need to analyze the what is my frequency value, how much amount of distance it transmitted. Based upon this frequency values only, we design this lambda value. Based upon this lambda value only, we design the my length of antenna values only. So here where we design the length of lambda value, L is in the form of this lambda values only. So L is equal to lambda, we calling as a dipole value, or as lambda by 2, we calling as a half wave dipole, or as lambda by 4, we calling as a monopole values only. Right, one is dipole value, half wave dipole value and monopole values only. So based upon this length value, based upon this dimension value, we design about this my antenna structure values only. Right. So in the basic elements of antennas are we focusing about this respective length of my antennas. What is the dimension of my antenna values only? How much distance it transmitted. So respective length values only, we are designing about this either short wave monopole value or dipole value or else quarter wave monopole values only. So here every antenna respective frequency we design a separate antenna values only. So particular frequency we design the particular antenna values only. So while coming to this parameters of antennas, so we discussing about this what is solid angle value, which means radiation intensity value, radiation pattern, side lobe levels, off-power beam width, full noise beam width, directivity, etc. etc. So these are the important parameter. While we design about any kind of antennas, we mainly consider about this respective parameter values only, because while we achieving the parameter with respect to the transmit section as well as in the receiver section, then only the antenna is practically working under the frequency values only, in the free space communication values only. Right. So the first parameter, as we discuss the first parameter, which is antenna radiation pattern. What is antenna radiation pattern? Antenna radiation pattern RS is a power pattern, which is nothing but how much amount of information is transmitted, right, into the free space communication. As we know, antenna is a wireless communication device. So once the signal is entering into the transmit section, how much amount of signal is scattering, how much amount distance it covers. So it is a graphical representation of how much amount of signal it covers an entire area, the geographical structure area values only. So here, what is radiation pattern? It is a mathematical function or a graphical representation of my radiation properties of antenna values only, which is in the space coordinate values only. So while we analyzing the radiation pattern, we are using these two different scenarios are there. One is field pattern, another one is power pattern. What is a field pattern? As we know, a signal is nothing but electric field value and magnetic field value. Based upon these field values, either the electric field value or else the magnetic field value, with help of this field pattern, we consider about the values only. We calling as a field pattern values only. And similarly, power pattern. What is power pattern? Based upon this, how much amount of power is producing. with respect to voltage values and current values. We are able to calculate about this, the power pattern values only. One is field pattern, which is electric field and magnetic field value. And the one is power pattern, which is based upon the voltage values or current values only. So one can able to see this normal power pattern. So here you can able to understand this half per beamwidth values only. And similarly, when you see this field pattern and power pattern, when we analyzing the half per beamwidth value, when analyzing the respective field values, which is the electric field value, when you see this E suffix R, which is the electric field range values only. One should be field value, other should be power pattern values only. So when analyzing the linear scale values in both the scenarios, which is the field values in the power values, we analyzing the linear scale value should be one range values only. But when we analyzing the difference between this power pattern and field pattern, we consider this 0.707, which is 1 by root 2 values only, and here we consider this 0.5 values only. So the difference between this field pattern and power pattern values only, how much amount of field it covers, how much amount of distance it covers. Based upon this one, we are able to take down the information values only. And apart from this one, when analyzing these values, so here when you see, here you also analyzing about this, what is the radiation lobe values and what is the beam width values, what is the radiation lobes. Basically when analyzing this lobe values, which means the power pattern values only. So this value we calling as a major lobe value, the high range frequency spectrum, which is transmitting the desired direction values only. And this we calling as a minor lobe value, which is the undesired direction values only, which means the values are very low values only, low radiation strength values only, which means my antenna is propagating in the desired direction. I can able to produce the frequency, or else I can able to transmit the frequency in the desired direction values only. So that direction we calling as a major lobe, and undesired direction, some amount of signal is transmitted in the undesired direction as well, that we calling as a minor lobe values or back lobe values only, or else we calling as a side lobe values only. So while comparison between this previous slide and this slide, so here we analyzing the field pattern, power pattern values only, the respective same values. But here we are able to see the values with help of this half per beamwidth value, right? Same range of this linear scale value. But here we consider the major lobe values and we consider the minor lobe values with respect to the back lobe values as well, with respect to field values as well as the power values. And what is half per beamwidth? The beamwidth between the two direction values only, two different angle values only, the respect to my radiation pattern values only, to respect to my major lobe side radiation pattern values only. From that we are able to calculating the half per beamwidth. Half per beamwidth we also calling as a 3 dB beamwidth minus 3 dB beamwidth. Apparently half per beamwidth is nothing but full nulls, twice of my full nulls beamwidth values only. So based upon this one, we are able to analyzing the radiation pattern. So while we designing about this any kind of antenna, first we focusing about the respective radiation pattern values only. How much amount of signal is transmitted, what kind of distance it covered, what kind of angles it covered, and what is the respective half per beamwidth values only. We analyzing the respective values. And in this session, we are focusing about functions of antennas and basic elements of antennas. So in the functions of antennas, we just cover about this 3 to 4 different various functions of antennas, and the basic element of antennas we consider the based upon this length of my antenna values only. In the next topic, we detailed discussion about these properties of antennas and what is the function of each and every element of my antenna values only. Thank you.